First question is how to draw pressure, volume and temperature entropy diagram for diesel cycle, which is thermodynamic air cycle. Second question, what are the different formulas that are useful to solve problem for the diesel cycle?
Let us understand how to draw pressure, volume and temperature entropy diagram for diesel cycle. As diesel cycle is thermodynamic air cycle, that is, air is used as a working substance in this piston cylinder arrangement. If we observe this diagram, here hot body, insulated cap and cold body, which we have to brought in contact with the bottom of the cylinder one by one for different processes. In diesel cycle, one process is taking place at constant pressure, one process is taking place at constant volume and two processes are taking place at the constant entropy. That is, two processes are the isentropic processes. Now we will understand how to complete the pressure, volume and temperature entropy diagram as per the different processes. Let us consider m kilogram of air is enclosed in this piston cylinder arrangement. And what is the initial condition of this air? So initial condition of air is at pressure P1, volume V1. So I will select here one initial point, that is point 1, which is having pressure P1 and volume V1. And it is at temperature T1. So here will be the point which is having temperature T1. Now we will start for the different processes. So what is the first process? So first process is constant pressure heating. That is, if we observe this diagram, this hot body is brought in contact with the bottom of the cylinder. And that is because of this hot body, the air is getting heated, but this heating process is taking place at constant pressure. So we have to show this process on these diagrams. So what is the effect of heating? So when air is getting heated, that means its temperature is getting increased. Now due to heating, pressure is also getting increased, but here pressure we have to keep constant. But because of heating, its volume is getting increased. So we have to show increase in volume at constant pressure. We have to show increase in temperature, and due to heating, entropy is also getting increased. So we have to show all these processes. So here I will show process 1 to 2. So here will be the point 2. Now at this point 2, the heat supplied is cut off. That means this point 2 is known as cut off point. So we will mention here this point 2, that is the cut off point. Then we will move for the next cycle, that is temperature entropy. So for this temperature entropy, we have to show increase in temperature as well as increase in entropy. So here we will show this temperature will be T2. Now during this process, heat is getting absorbed by the air, and what is this heat absorbed? Q12 is equal to, now this is the process taking place at constant pressure. So we will say that here specific heat at constant pressure, that is Cp. So which is equal to mCp T2 minus T1. So here P1 is equal to P2. We will write, and at point 2 here is volume P2. Now we will move for the next process. So next process is the process 2 to 3, reversible adiabatic or isentropic expansion. Now what is the effect of expansion on this pressure, volume and temperature? This process is isentropic, that means we have to keep entropy constant. Now we know that during the expansion process, pressure is getting decreased and volume is getting increased. And when pressure is getting decreased, temperature is also getting decreased. That means we have to show decrease in pressure, increase in volume, decrease in temperature. So I will show here. So here pressure is getting decreased and volume is getting increased. So I will select here the point 3 and we will join these 2 points. Here we will show arrow. So volume is getting increased, then pressure P3 is getting decreased, and this process entropy it remains constant. So I will draw here straight vertical line. Temperature is also getting decreased. So here will be the point 3, that is temperature T3. So we will show here arrow, and here S2 is equal to S3 and at point 1 entropy is S1. In this process no heat is absorbed or rejected. Now we will move for the next process 3 to 4, constant volume cooling. So here cooling process is taking place but it will be at constant volume. So we have to show here the constant volume and cooling process. That means if we observe this diagram, here the cold body is brought in contact at the bottom of the cylinder and due to which air is getting cooled at constant volume. So what is the effect of cooling? So when the cooling process is taking place, that means its a temperature is getting decreased, and when the temperature is getting decreased, that means pressure is also getting decreased. So this is the relation in between pressure and temperature. Pressure increases, temperature increases. Pressure decreases, temperature decreases. So we have to show that relation. Volume that we have to keep constant. Now during the cooling process, what is the effect on entropy? So whenever the cooling process is taking place, that means entropy is also getting decreased. While heating, entropy increases, and while cooling, entropy decreases. So I will show here. So here will be the point 4 and I will say this is the pressure P4. And now we have to show decrease in temperature and decrease in entropy. So here I will show below that T3 we have to show here the point 4 and here will be the temperature T4. Now in this process some heat is getting rejected and that is equal to Q34 is equal to mCV T3 minus T4. Now why CV is used? That is the specific heat at constant volume, because this is the process taking place at constant volume. So here V3 is equal to V4. Now again we will move for the next process, process 4 to 1, reversible adiabatic or isentropic compression. So compression process is taking place. So what is happening during compression? Pressure increases, temperature increases, volume decreases. So we have to show all these processes and entropy remains constant. So first volume is getting decreased. Now this is the process 4 to 1. So point 4 is here, point 1 is here. So pressure is getting increased. So pressure is getting increased from P4 to P1 and volume is getting decreased from V4 to V1. So I will join these 2 points and here will be the point. Now we will show here temperature is getting increased, that is from 4 to 1 and we have to draw straight vertical line. So S1 is equal to S4. And during this process no heat is absorbed or rejected by the air. Let us understand some formulas related to diesel cycle. Work done is equal to heat absorbed minus heat rejected. Now if we observe this process, then heat is getting absorbed during the process 1 to 2 and which is at constant pressure, and heat is rejected during the process 3 to 4 which is at constant volume. So what is the formula? mCp T2 minus T1 minus mCv T3 minus T4. And how to calculate efficiency? So efficiency is equal to work done by heat absorbed. So we have to write all this formula divided by heat absorbed, that is mCp T2 minus T1. Now if we observe this mCp T2 minus T1, from numerator and denominator is getting cancelled. So here will be 1. So 1 minus. Now here mm is also getting cancelled. Cv by Cp into T3 minus T4 divided by T2 minus T1. Now we know that gamma is equal to Cp by Cv. So we will put here Cv by Cp, that means 1 by gamma. So here I will put 1 minus 1 by gamma, and remaining we will write T3 minus T4 divided by T2 minus T1. So this is the formula to calculate the efficiency. Now we will understand different ratios. So first one is the cutoff ratio. Now we know that at point 2 heat supplied is cut off. So what is the cutoff ratio? So that is the ratio of volume at point 2 divided by volume at point 1. So we will give here the notation cutoff ratio rho is equal to V2 by V1. Now we will move for the compression ratio. So for compression ratio we will give notation R, and this compression process is taking place during the process 4 to 1. So here we will take the ratio, that is V4. So here V3 is equal to V4. So we will write here V4 divided by V1. Then we will move for the expansion ratio. So here during the process 2 to 3 expansion is taking place. So we will give notation R1 is equal to V3 by V2. Now this V3 is nothing but V4. So we will write here V3 is equal to V4, that is V4 by V2. Now we will multiply and divide with for this ratio with V1, that is V4 by V1 into V1 by V2. Now what is this V4 by V1? So V4 by V1, that is nothing but compression ratio R. And what is this V1 by V2? So this V1 by V2, that is V2 by V1 is equal to rho. That means therefore 1 by rho is equal to V1 by V2. So we will write here 1 by rho. So we can say that therefore R1, that is expansion ratio, is equal to compression ratio divided by cutoff ratio. So this is the relation in between this.